I just want to take a second to apologize. As I'm editing this video, I realized I might as well have been recording with a potato and not an actual webcam. I also completely screwed up on the audio. The little microphone that I was wearing was not plugged in. So, yeah. This is going to be a very long video. I'm going through absolutely every step with details. A lot of you will know most of this, but I've had a lot of comments on the posts I've shared where people are saying, well, how do I solder and how do I do all these different little steps? So I'm going through absolutely every step in this process. So in our last video, I promised we were going to put together a tier net box. There's only one problem with that. I already did it. I went on a spree soldering things together and put all of my light boxes together. So, tell you what, let's go ahead and do a different one. I've made up the logo for the Death Corps of Krieg. I wanted to make one for my cousin. And did a couple things different on this one. First of all, I'm doing a two-tone on the face. So using white for the outside edge and then eSun's Bone White, which is kind of a khaki color for the face itself. Doing a few things different on the inside as well. I put together, because of the curved shape on this, I put together a little, I don't know, call it a mouse hole, to give a flat surface here for the nut that will hold the power jack in. And I recessed it a little bit on the front to give it a flat surface right here that hopefully that's big enough for the plug to fit in. I think it's a little bit oversized. We'll see how that goes. And other than that, it's the same thing as all the other ones. Same little cutout right here for the, I'm sorry, it keeps flashing. Same little cutout for the power switch. Same keyhole as everything else. I did do on this one my little retainer. This is going to use a heat insert. If I change over to showing the face and let's look at the bottom real quick. There's a space right here for a heat insert M3 nut to go into. And from the base, a little hole where you can recess an M3 pan head screw into. So even though I'm pretty sure the geometry on this one will hold it together just with a friction fit, because I had a nice space in the middle where I could put that, I figured, well, let's go ahead and do it. So I've put this together. I've already gone through and modified all the settings that I need. Just as a quick reminder, I'd like to come through and on the base plate, I'll change that. Oh, I don't think I have. Nope, don't have developer mode on. Always make sure you turn developer mode on. On the base, I'll go through and bring the top shell layers down to 3. We don't need 4, because if we slice this and take a look at it, and change back over to line type, and I went over this in much more detail in the first video, where we have our first top shell layer, these blue lines, I've rotated the infill to go pretty much perpendicular to it. Not exactly, but pretty close. And that's done by rotating the infill direction down here. So I'm expecting this will print nice and quick. I've got the speed on my bridge layer turned up, not super fast, just 150. But that way it will print this blue layer in third of the time it normally would. I think the default on this is like 50 or 30 or something, because bridges usually like to print slow. But we're going to speed it up, and hopefully that'll shave some time off of it. In fact, if I come back down just for looking at it real quick, our print time right now is 3 hours and 19 minutes. If I turn this back down to 30, oh, and 143 grams. So 143 grams, 3 hours, 20 minutes. I put the bridge back at 30 and kick my top shell layers back up to 4 to get the same effect. Let's see what we look like now. 3 hours or 4 hours almost, and we went up almost 20 grams or 12 grams. Yeah, so more material, more time for the exact same result, and this isn't a super structural part, so why do it? Anyways, I'll get these things printed and go from there. Actually, before we print it, let's talk about something else. On surfaces like these, where we're going to have a lot of color changing happening, well, not a lot, but color changing nonetheless, I've changed the default order on this. I want it to print my translucent colors first. You can do that over here in the little hex nut. You can change the order that the filaments go down. It's a wonderful new change in Studio 174. I've done it this way primarily because if we go back and look at the preview, it's going to start by doing my white, well, my bone white, then it's going to do my white, then it's going to do the black. The idea here is that I want to be able to find those little wispies that are going to come up from the black filament, having the contrast of the white material. But also, I don't want those little wispies to be down on my first layer before any of this other material goes down. It shows up in the Lightbox, it shows up on the surface, it doesn't look good. So I want to make my opaque color the last thing to go down on the first layer. That will go down, and then on our second layer, it will start with the black. Here, let me kick that up to layer 2. It will start with the black again, finishing off what it had started. And when it gets to this point here, when it goes to do the color change from black over to the next color, I'm going to have a minute to go in and inspect and try and clean up any wispies that might exist. Because when the next color comes down, if there are any black wispies, it's going to start putting my translucence down on top of them, and I don't want that. It's best to do this by inserting a pause or hitting the pause button on the printer. I'm going to do it live. I don't recommend doing it live unless you're very familiar with the sounds your printer makes, so you can focus on finding those wispies and then knowing when it's time to get your hands out of the way. It can hurt you. It can hurt the printer. I don't recommend doing it. Pause the printer, but I'm going to do it anyways. All right. Whispies are the enemy of lightboxes. I've got my toothbrush. I've got my clippers. And here's our color change. So this is dangerous. I don't recommend doing it, but I'm going to look for anything that pokes up. Right there, there's one. Very gently go in there and clip them out. If these get put down in the next layers, they're going to show up really badly when you backlight this thing. One right here. Part of what sucks with finding black wispies is that when they get pulled, they turn white. So you can't see them very well, but they will show up when you actually go down to print, or when the next color comes down. So, it takes about a minute for the AMS to change colors. That's how long I have to try and get these out. Another unfortunate part about this, the face for this light box takes 2.5 hours to print. This color swap happened at 43% into that mix. About 10 seconds. That's it. Get your hands out of there. You do not want to hit the head when it's moving full speed. I guess we'll see how this looks when it finishes. We're can see here we're putting down the first of the top shell layers, and by having the infill running virtually perpendicular to it, it's not perfect but almost perpendicular, it's not causing any problems as far as having any kind of bubbling or whatnot. There is some texture to it, yes, but it's much worse by the eye than it actually is to touch. And when this finishes putting down the other two layers on top of it, it's going to be nice and smooth with only 3 shell layers. So I need to apologize. I realized 3/4 of the way through this that my lapel microphone was unplugged and I was being recorded by my laptop. Also, I'm using some very old webcams and they suck. So if you bear through this, thank you. Alright, so here is our Tyranid lamp. I kind of got excited and went ahead and put it together already. Did that the other night. Everything's in here. Switch turns on, all that good stuff. Lights up pretty good. There we go. So that one was pretty cool. But you want to see how to put these together. So that's alright, because I've got another one. I put together another lamp for the Deathcore Krieg. Did a few things different on this one. For example, I added in, there we go, added in a little feature right here. I don't know if I can get that on the camera, I'll try. There we go. I took a guess at the size of the DC Jack as far as getting the bolt on the inside of it to try and get that squared away. Other than that, same stuff I've done everywhere else, same little keyhole. Any one that supports it, I like to put in these little pegs. That'll be an M3 screw that goes in on the back. That'll pierce through. We're going to do a heat insert into the little mating peg here. The way those go together, this one, the geometry works pretty well. It sticks together pretty good on its own. Some of the other ones, though, if I have the ability to put these little pegs in them, I really like to, just to make sure they don't come apart and I don't have to put glue in them. So I guess we'll go ahead and get started on that real quick. The heat inserts are pretty easy to do. I got a kit, Amazon, wherever it was from, I don't remember, that has the little heat insert tip. It was, I think, like $8 or $9. It wasn't expensive. Let's go over here. I've set my soldering iron to 250 Celsius, which is all you need for PLA, all you need for any of them really. I'll just put the heat insert on top. Give this just a second longer to make sure it's fully charged up, fully heated up. And doing this too hot, it'll go real fast. Doing it nice and cool, you can get it in, no big deal. If this were turned up way hot, it would definitely have just sunk in super quick, and yeah, don't want to mess it up too bad. Cools off pretty quick, so that part, nice and easy. I don't know if the focus is working or not. If it isn't, I apologize. But that's all we have to do for the face of our Krieg lamp. On the base of it, I'm going to do a few things. I've got the same little Same little DC plug, little single pole, single throw switch, just a little micro switch. I like these. The specific part that I'm using, links are in the project files. Little 5.5, 2.1 millimeter barrel jack. Same thing, just cheap. I got a bolt pack of like 20 of those for like $5. Need some wire, obviously. I looked at what I had available for LEDs, and I had a bunch of different colors, and I decided with this one that I wanted to go on white. When I put the model together, I decided to use white on the little accent line, and then this is eSun's Bone White. It's my first time using it for a Lightbox. Gives a nice khaki effect, I hope. Went a little bit thicker than usual. I usually do these 0.6 millimeters, but I added another layer, made this 0.8 millimeters. So we'll see how that comes across. Let's see here. One of the things I like to do when I'm figuring out how much of this I'm going to need, and this part always takes forever, trying to deal with the stupid tape on these things. It either comes off or it doesn't want to work right. Come on. Try to get your fingernail underneath it to pull back just the plastic but not the adhesive is always fun. There we go. I'll pull back a little bit of it. And I'm probably going to start this one, I don't know, over... I like to start them on a flat area so they can get good purchase. The bottom of this model does not have very much flat area. So I'm just going to stick it here. And I'm only doing the very bottom of it. I'm just going to kind of loosely rotate around and pinch as I go to figure out how much of this I'm going to need. As long as I keep one hand on here all the time, I won't lose my place. It doesn't have to be exact, just close. So probably right about there. I'm going to go ahead and clip off one length longer than I actually need. I'd rather lose 2 inches of my strip than find out that the rest of this is unusable. This one was a little bit cheap. I like the ones that usually have the divider to be a little bit closer. Like on this one, it's every 2-something inches, 2.5 inches. There we go. So these little contacts are where you cut these at. You don't want to cut anywhere other than those little contact parts. They actually have a little line on them showing where you should cut them. I'd rather lose this little extra piece right here than realize that the rest of the strip that I just cut off is no good to me. So anyways, back to the other camera. Now that I know how much I'm going to work with, take this out. I'm going to start soldering. I have a couple things that we have to put together. I'll stay there. Although by now, soldering iron should have cooled down. And cool enough. Take the heat insert tip out. Not to burn myself. The actual soldering iron tip back in here. You can do the heat inserts with a regular soldering iron tip. You don't have to have the brass inserts, but they do make it a lot easier. Just stuff that away for now. We're going to need a finer point for the soldering. The little strips don't want to damage them. Okay, so we'll start off with our wire. The goal that I have here, what I want to do, I'm going to have my DC Jack, and I need to, of course, connect my 2 wires to here to get power inside of things. I'm going to take the red wire for positive, run that over to the switch, then run the other side of the switch out to our LED strip. It'll be one that's marked 5 volt, so I'll put the red one on that. And then the black wire coming directly off the plug will go to ground. The way this is put together, kind of have to do this in stages. If you solder everything together, you won't be able to put it together, because when you go to put your switch in, you won't be able to get, get your plug in, you won't be able to get your switch in too, because they'll already be soldered together. So some of this is done inside the box. As long as you're careful with the soldering iron, even using PLA, you'll be okay. Which I guess now is as good a time as any just to see if the plug even fits. Part of what I was trying to figure out on this one, I wanted to see if that would fit, and it looks like it does. There's a little bit of extra around it, but that's okay. I'm alright with that. That gives it a flat surface to go against instead of this rounded surface. It has that flat edge, and no, it fits in there nicely, I think. And then on the inside of it, I put that little feature in here, and you can see this on the model. That'll give it a flat edge for the bolt or the nut to go against. Because otherwise, when I go to put this nut in here, it would be on that rounded surface and it wouldn't have a good purchase area. So that looks like it's going to work just fine. Check that back out for now and put you aside. Alright, I'm just going to start off with our red and black wires. Wire stripper, come in and take off just a little bit. Go ahead and do both ends of the plug first just to get it out of the way. And our soldering iron in a minute, we'll get that warming up. These things are wonderful. If you're doing soldering work, they are your best friend. Because you don't have enough hands to do the soldering by yourself. And getting your 8-year-olds to come out and help you do it is not very productive. So let's see if I can get this in frame. I'm just going to take my plug, stick it in there. I like to roll these over. I doubt you'll be able to see the detail on it, but on these multi-core wires, which are best to work with in my opinion, just a little twist on them so that the fabric, whatever you want to call it, stays together. Trick with soldering. Make sure your iron's hot. Right now I'm only at 250. That needs to be higher. I'm going to go up to 400 Celsius. Having that good and hot ensures that you're going to melt things quickly. Even at 250, it's enough to melt the plastic. And if you give it time to heat up the metal enough to melt your solder, you're going to melt your plastic first. Get your soldering iron hot. Get it up to 350, 375, 400. And a lot of times your solder will tell you what temperature it melts at. I don't think this one does. There is low temperature solder, but I've got some old MG chemicals here. What I'll do, I'll come in, and I've got a nice hot soldering iron now. Touch it at the contact for just a second, and then run your solder onto it. Shouldn't take any up. Don't forget to turn on your soldering vent. There is lead in this. I breathed enough of that as a kid. I don't need any more of it now. I used to do this kind of work with my father in the garage, so maybe if I pull this thing back, it'll give it some contrast. Try that. You see better. So a little vent on. Hooray! That was another fun little project this time. There's a million of them on Thingiverse and wherever, and I decided to make my own. Didn't work great. You see, I had a heck of a time printing that hex grid out. It's ugly. That's what I get for trying to use PETG. I suck with PETG, but I wanted to do it anyways. And I'd found a pretty cool little. I buy stuff off Amazon when I really shouldn't. I found a little USB-C adapter that would let me. Oh, wrong way. Let me put a USB-C port on it, and I got like 10 of them for $8, so I really wanted to play with it. And that was the project on this one, but whatever, put that back. Stay on this. So hopefully we can see that all right. I hope you can. So back to soldering. We did the negative contact. Need to come in and heat this guy up a little bit, second or two. Get our solder on. Do the same thing for the wires. Kick this guy out. Do our wires real quick. If you can, it's best to hold your soldering iron and your solder on opposite ends of the wire. Let the heat from the soldering iron get through the wire. That way you're actually putting solder into the wire and not just on your soldering iron. If you try and melt the solder to the soldering iron and then put that in the wire, it's not going to work. You have to heat the wire up so it'll absorb that solder. So put our plug back in. On these particular plugs, the short one is our positive contact. So I'm just going to take our wire, put it up next to this, touch a soldering iron to it, and what I'm watching for is for that solder to liquefy. As soon as it liquefies and you've got a decent contact, take the soldering iron away, hold the wire still for a second. As soon as it solidifies, your wire is bonded. There are tiny little holes on here. You can try and feed it through the holes if you really want to, but it's not necessary. Try rotating, see if I can get my fingers out of the way. I was watching what I was doing. I wasn't watching my head-up camera. I think you can see me now. So I'm just going to touch that. And what I'm watching for is for that solder to liquefy. And then we're good. I'd zoom in more, but this camera sucks. I'm sorry. If you want soldering demos, go watch Electroboom, I guess. That guy's great. So, clean off the tip. I need to get my heat shrink. Got all my tubs of stuff on the side. Heat shrink is a wonderful, wonderful thing. Little bitty 1/16 here, that'll be fine. Generally speaking, you don't have to heat shrink everything. I like to at least do my positive contacts. Drop that down in place, and the soldering station I have comes with a reworking tool, a soldering reworking tool. This thing is basically just a very focused, high-power hot air gun. I use it for heat shrink. So, cables everywhere. Clean up that mess real quick. I'll try and do this closer to the camera, see if we can't see it a little bit better. Be careful not to blast your fingers. I've got it set for 275 Celsius right now, so I don't want to blast my fingers with it. But just a few seconds on each side, and it'll shrink up nice and tight. See if it'll focus. Come on, focus. Nope, not going to give me focus. It'll shrink up nice and tight, and that's it. You're done. Right, like I said, you can do all of your contacts if you really want to. I'm just doing the positive because I don't think it's necessary to do any of the rest of them. That side done. What can we do next? Honestly, at this point, even though it's probably not the greatest thing, I'm just going to go ahead and start putting things in. That fan will turn off in a second. It has an auto cooldown. Sorry about that. So with those done, feed wires through. I have noticed that these holes have a tendency to print with a little bit of a flat side on them. So since these jacks have a flat side as well, I try to line those up. Basically put the flat side up and down. And I know you can't really see what I'm doing. I'm just tightening up the little nut here. Get it as far as my fingers will go, and that works wonderfully. Take a pair of pliers, just kind of torque it down some. This is solid in between here. I'm not worried about busting the model or busting the jack, so I'm going to put a little bit of Gorilla on it, maybe a quarter Gorilla. That's about all we need. So now that's anchored in. From here, the next step is going to be soldering it to the power switch. So I'm just going to go ahead and take that guy. Actually, before I put it in here, just to simplify how much I'm actually soldering inside of there. Get one of our arms back down here. There we go, now we're in the middle. You can see it. Find the solder. I'm just going to pretend these. Getting solder on them before putting them in there. It's just that much less where I have to hold the soldering iron. It's just that much less time where I have to hold the soldering iron inside the plastic. So less chance of melting something. Throw a whole bunch on there, why not? Not going to hurt anything. Same thing as before. These little switches, they do have holes going through them, so you can try and feed the wire through it if you really want to. I don't think it's necessary. Sometimes it actually makes it more difficult, but we're okay for now. So take this guy, and these are just little pressure fit. They have little ribbing on the sides of it that when you click them in there, they're in there. You can get them back out, but snaps in, and that's that. Take our red wire. I guess I need about that much. Snip that off. Take our stripper, put it in the right slot. Pull out about, I don't know, 4 or 5 millimeters at a quarter of an inch, something like that. Go ahead and pre-tin this wire. And just hold the soldering iron one side. And there we go. Some solder on it. Before I go any further, I want to get a different piece of heat shrink. I think the 3/32. Oh yeah. So the original piece I had was too small. It fits over the wires great, but it won't fit over the plugs on these. The little plugs on the switch. So I'm going to cut a slightly larger piece, a higher diameter, a little bit longer. Go ahead and feed that over my positive wire. Just get it out of the way, pretty much as far away from your solder as you possibly can. Use fingers, tools, whatever. I'm just going to use fingers. They're kind of in the way. I don't know if I can rotate this maybe. Give you a better view of it. There we go. Hands are probably going to be in the way. I'll try and do this left-handed, try not to burn myself in the process. So just come in, hold it against that contact, it liquefies, it's solid, it's done. It literally goes that fast. It does not take long, especially if you've already pre-tinned. If you have no solder on your contact points, you're going to have to hold it there longer. You pre-tin it, it goes in nice and easy. So we'll be able to put our heat shrink over there, but I'm not doing that just yet. not enough wire. That little piece that I had left over. I'm sitting here thinking about where I want to start my light strip at. And I could use this little piece, I guess. That's not going to give me a lot to work with to try and get this to one side or the other. I'm just going to grab another piece. There's this one. And when I started making light boxes, I realized I was missing like all of the different supplies that I would need, so I kind of went on a bit of a shopping spree. Got all the stuff that I need, a couple spools of different wire and whatnot. You can do this with pretty much any basic wire. You can get it at, I mean, Walmart sells it, any auto parts store. I think the auto parts stores, they call them primary wire. In fact, one of my older projects, I'd gone out and I needed some slightly heavier wire. So I picked up a whole bunch of these for like $3 a piece at O'Reilly or wherever. Just handy to have. I've gone through and picked up, depending on the lights I'm working with, some 4-strand for RGB. Went out and got some 3-strand for ARGB. Just a nice little assortment. For these though, because we're doing them cheap, and we're doing them easy, it's just 5-volt DC. There's no special connectors needed or anything like that. Like, we're not making JST connectors. We're not doing any of that kind of stuff. All you need is just 2 wires. So, same as before, take a little bit off the end, twist that up, bring some fingers down to help out, find my solder again. I didn't get a good twist on that. Good enough. My fingers are dry, they're not biting the wire very well. Heat it up. I'm a little bit far away from my vent, but it's working, I guess. Just don't breathe in. What was it the Blend-O-Matic guy said, or Blend Tech, don't breathe this. Tiny bit ain't going to hurt you, but at the same time, long-term exposure to lead does lead to a myriad of health issues. Look at what happened in the 80s. That's actually some really cool documentaries on that. Scary documentaries, but cool. So we'll put that one in. Same thing as before, I'm going to need a little chunk of my slightly larger shrink tubing. Again, it's not necessary to do that. It's not like this is high voltage. It's not like a short's going to be the end of the world. I like to do it anyways. I think it's just a good thing to do. In this case, to get these put in, I'm going to turn my soldering iron back down, probably like 250-ish, somewhere in there. I'll give it a second to cool down. I'm going to take the soldering iron and come in here and just kind of gently rub it on the heat shrink. It's fine. Don't hold still. Gently brush and move. Gently brush and move. Especially if you've turned the temperature down on your soldering iron, it's not going to melt through it. A lot of times the stuff will say what it's rated for. Like my 20-year-old Tektron here says up to 300 degrees for short duration. So I set it to 250. I'm fine. I'll be able to shrink it. No big deal. While the soldering iron cools down for a second, I'm going to pause the video and get a drink because my voice is starting to dry out. Alright, soldering iron's come down to temp, and I'm going to melt the heat shrink. So, I hope you can see it. It's going to kind of gently push it around, almost like I'm brushing it, the soldering iron. And what I'll typically do is like do one side, do the other side a little bit, and if you can, if you haven't melted it too much, nope, I melted too much. I like to roll it over so I can try and get to the bottom. I bet you I can still roll it over. Yeah, there we go. Pull it back some, flip it over, put it back in place. That way the bottom side of it that I can't get without melting the plastic, I can get it. Because my temperature is low, it's not melting super fast. I could use the hot air gun here, but remember PLA deforms at like 55 degrees, so by blasting this with hot air, I would melt and deform and possibly even ruin the base of my box here. And I don't want to have to print this again. That was 2.5, 3 hours. The base was 3 hours. I don't want to have to do that again, so I'm not going to ruin it. Plus, this is a gift from my cousin, and I want it to look nice. So this does take a minute when you're using the lower heat like this, and I'm moving back and forth fairly rapidly so that I don't hold too much heat in any one place at any one time. If I sit and hold, it'll definitely shrink, but I run the risk of burning through it, melting the protective coating on the wire. Just not worth it. That plastic, by the way, will gum up on your soldering iron tip, so I like to really run it through the tip cleaner and the scrubby, and if you're using a sponge or whatever, just make sure you get it off there. It's not good for it. That done, let's turn the soldering iron back up because we're going to go back to wires. Go back to 400. At this point, we've done the hard part. I can take a DC Jack and plug it into the back, which everything I've used on these, it's a 5.521 or 5.5 millimeter to 2.1 millimeter. And what that's telling you is the outside diameter on the plug. Move this out of the way. The outside diameter on the plug is 5.5 millimeters, and then the inside pin is 2.1. For 5 and 12 volt applications, it's like the single most common plug that exists. That's part of why I chose it. They're common, they're cheap. Plus, they're perfectly fine. So, next stage on this one, and this is going to get a little bit interesting. Also, why I use some longer wire. I take these, knock the ends off, and I'm being careful when I pull to not pull against where I've already soldered things down. I'm bracing my hand and pulling away. I'm not pulling with this hand because I don't want to yank these off of where I've already soldered them in. I could have cut these earlier and tinned them first. Always a good idea, but I didn't think of that because I'm distracted by making the video. I'm going to pre-tin these real quick. Get it in the helping hands and throw some solder on them. Even with the helping hands, I don't have enough hands. Clean the tip off. One of the things about solder, it oxidizes. And you don't want old solder oxidizing and ruining your tip. That's why you keep it clean. The other end of my iron here, get that out of the way. I've got a little stand for it to hold it, but in here they also give me this brass scrubby, and inside of here is some cleaning resin, or what is it, flux reservoir, resin flux. So I'll just stab it in there and make it nice and clean. I don't have to use the resin nearly as much as I do, but just out of habit, I do. Anyways, we've got our wires pre-tin. And what I didn't do, what I should have done when I was looking at our wire, and I got lucky just now, when I was looking at our LED, on these contacts, and I'm whited out again. I don't know if I take this one, get rid of the contrast, maybe that'll help me. There we go, now we can kind of see. Nope. This Logitech sucks. I'll superimpose a picture if I have to. The way they put these together, there is all of these little copper contacts, however far apart they might be. Different strips have different lengths. And every so often, you're going to find where they're soldered together. Like in this case, I cannot tell if I'm in focus or not. In this case, there's some crudely done solder on here. All of these are like this. The factories that make these things, they do them in like 1 meter strips or whatever length, I forget. And then they just solder them together and make the spools. So I'm going to make my life easy. Instead of having to get my flux out and painting these and having to clean them up afterwards, I'm just going to use where there's already an existing solder point. It's going to make life easier. If you don't get lucky, if you don't have the ability to do that, where you cut the strip, you don't have one of those, don't worry about it. You'd get a little bit of flux paste, like this. It's just looks like earwax, I guess. I take a pair of tweezers and just put a tiny little bit on those contacts. It melts out real good. Gives you protection against the oxidation. So your solder will actually stick to the contacts. I've had it happen way too many times where I'll be trying to put something together and I can't because the solder won't stick because it's oxidized and it's just not fun. Where'd my wires go? This is the part that's kind of fun, and I'm hoping I can do this without blocking your view. Because I don't want to do this holding it. I want to do this against the little silicon mat. But finding the side that says 5 volt, I'm going to put my red cable down, and then ground, I'm going to put my black cable down. I do this a little bit differently. I do it in line, I guess would be how you'd say it. I bring the wires from the direction of the strip, so that when I go to actually put this on the light box, and I'll try and pinch it down and show it. I'll just have to show it later when I get my fingers out of the way. The idea is that the wires will be moving with the shape, and the light strip will be moving with the shape. It also makes it easy to put a chunk of heat shrink over it just to protect it some. I'll get a bigger piece that will fit over. This one doesn't. 1/4 inch will definitely fit. You get a bigger piece that fits over this tip, or over the end of this, which means with my wires coming down the LED strip this way, I'll be able to throw the heat shrink over the end of it and actually do something with it. You can, of course, have it going the other way, where wires go in and heat shrink goes in, and it would look more like that. You can do it that way, for sure. There's nothing wrong with that. I just like doing it the other way. I don't know if I'm going to be able to put this in a manner where I'll be able to reach it and you can see it. I will try. Of course, my hand is in the way there. And this. I can do it this way. Yeah, that might work. Now, gives you a new respect for the guys who do this all the time on YouTube and make it look easy. Okay, so I'm just going to line these up, and I am all but certain that is not in focus or you can't see it. And if that's true, I'm sorry. But I'm just going to line those up so that the wire, when I'm not pushing on it, is in line with my contact. Soldering iron to the top of the wire, push down gently. Once it all melts together, oh, I missed. Once it all melts together, you're done. Do the same thing for the other one. Try and bend this so that without me having to flex the wire, it wants to be where I want it, because I'm not going to be able to keep pressure on it with the soldering iron. If I try and hold it down with the soldering iron, it'll stay molten and it won't adhere. So I want that wire to want to go down into that contact. I want it to want to fall into that contact. There you go, just like that. So at this point, we have an LED strip connected to some wires. We're actually ready to test this, and before I go any further, that's exactly what I want to do. I want to light this thing up to make sure that the entire strip works, that my solder work is good, because if I start sticking this thing onto the lamp, well, it's going to make it really hard to come back in and undo it. These little sticky strips aren't, they're reusable. I don't think they are. Oh, my switch is already on, so yeah, it definitely works. So, yay! I love lamp. And just as a quickie to see what this is going to look like, kind of stuff everything in. Grab our face. I'm not going to screw everything. I'm just going to put it on top there, and well, I'm just going to not worry about the lights. Hey, look at that. We have a lamp. So, get the face out of the way. I do not have my alcohol wipes. I'll be right back. I forgot an important part of this. Okay, so what I forgot was a little alcohol wipe. I've been handling this. I've been touching it. My fingers have oils on them. Sorry, wrong button. I was saying, okay, sorry. So what I forgot is my alcohol wipe. I've been touching this. I've been handling it. And just like you don't want to handle your print bed because it's going to cause adhesion issues, I'm going to be sticking, and this is part of why, I'm sorry to change subjects, part of why I like putting this glow-in-the-dark strip in here. I'm going to line my LED strip, the top of it, right along the bottom of this glow-in-the-dark part. And when I go to put this on, the adhesive on here, it'll probably hold just fine. But if I come in here first with a little alcohol wipe and rub down this surface, clean, just get it clean. Let's unplug this thing too. Don't get it plugged in right now. Just a quick little wipe. Once this dries out, it's going to ensure that this strip holds on really, really well. This particular lamp having a screw holding it together, well, it's friction fit and the screws is kind of their benefit. I'm not terribly worried about it. If the strip comes off, we can get back into it, replace it, put a new one into it, whatever. On the ones that I have to glue together, though, well, you're probably going to break the thing trying to get it back apart. Even just a couple little dabs of super glue, they're going to bond really, really well to all the voids in the plastic, and it'll be a bad time. So now that we've tested it and we know that it works, I'm going to clean up this end real quick. I'm going to take my little side snips, side cutters, whatever you want to call them, knock off the ends of the wire that I don't need. I had a little bit too much there. Try and get it a little bit closer to flush. Doesn't have to be great or anything. And I'm going to take just a little bit of a heat shrink, throw it all over the place. And I'm just going to take that heat shrink, put it over the end. Oh, actually, I want to peel back a little bit of that plastic first. And this is really just to protect the wire some. Whatever. Get our heat gun back on. Sorry if the microphone picks this up really loud. Yep, definitely hot. kind of wave back and forth. And if I get in the way of the camera, I'm sorry, but I need to come from the other side too. I don't know if you see it shrink up real good. Just give it a good blast. What I like to do while it's still hot is it kind of gets soft and sticky. Take a pair of pliers and squish together that end. Just so nothing goes in the open side of it. As long as it's still warm when you do that, it'll bond fairly well to itself. So from here, it's just a matter of getting the strip in. Peel back a little bit from there, and rotate this around. Basically, this is the range of movement I have with how much wire I have. I can go anywhere those wires will go. Since it's already facing this way, I'm just going to go this way. And I don't know if we're the way that is. I'm just going to start here. Why not? Go back over the strip. Go right for the top of that accent line. Just kind of push that in real good. And then I'm going to do a little bit at a time. Pull back an inch or two. And part of what I do on the designs of these, where these would normally be sharp points, which are a real pain to wrap lights around, I put fillets on here. It does cause problems in printing, where instead of having a continuous wall all the way around, at some of these it'll have to come in and stop and go back, and you get a little bit more travel. It adds some time. It's not that big a deal. But just starting from one side and working my way over. Put those down, and I try to look a little bit ahead to make sure I'm not going to go up or down, that I'm going to actually keep it where it needs to be. And I know my finger's in the way, I'm sorry. I know the way to do this. But basically just one little segment at a time, and I'll come back and just push into it a few times just to make sure that it's bonding well. Where you do these harder turns, the strip wants to just naturally spring back out. It's nice when you actually have really strong internal, or really small areas that it'll, as it goes in, it'll kind of wedge against itself and push it into the walls. Okay, just realized my microphone's not even plugged in. Anyways, you can kind of work around little bit by little bit. This is one of the things I like about these cob lights too. They are much more flexible than SMD LEDs. The ones that have the little squares on them every so often. Aside from giving you a more uniform light, and I think even a better light, and has a higher CRI and whatnot, they're more flexible around these corners. You don't have to worry about resistors popping off or the actual SMDs themselves popping off. Now, in this particular lamp, we've got a hard 90. I did run the fillet around it, but I'm not going to try and push it into those corners. I'm just going to get it reasonably well in. It's going to be fine. There's going to be enough light in here. I'm not worried about it. Another thing too, these little solder points, they are brittle. If I were to really try and bend that point around one of these corners, if I was unlucky and it lined up like right on this corner, it absolutely would snap. I've repaired those before by putting just a little piece of wire and soldering it back down, but they're never terribly strong. So I try to avoid putting those on hard bends. And just keep going around. So at this point, we've got a little bit of overlap. And I'm perfectly fine with that, because my option is either to cut it off right here, and then from between my fingers I'll have no light at all, or I can just push it down on top of the other part, the back end of the strip, and have a little bit of bonus light right here, which I think is perfectly acceptable. I can try and stick it against the back of the heat shrink from where the wiring comes up, and that'll work just fine. I'm going to try, though, to leave the protective cover for the sticky to where it won't try to bond against the other strip. These do put out some heat, so I just want to leave a little bit of distance between them. Stacking them on top of each other, not the greatest idea. If I really wanted to, I could throw my leftover heat shrink on it, but I don't want to do that. I'll throw the lid on this and see what it looks like as is. I do like to try and keep things a little bit tidy, so I know my hands are in the way. I have stuffed the wires down a little bit. A lot of people use electrical tape. I have some wire harness tape, so stuff they use putting wire harnesses together in cars. If this will handle the heat of being inside of a motor cage, it will handle the heat of some LEDs. It bonds really well to itself, so just a little piece of this stuck around the wires. I'm going to do that. I'm going to put a little bit right here, this part. No, yeah, I've got this little piece already cut up, so I'll throw it on the part going to the switch as well. And as I've said a handful of times, we're not making rockets for NASA. It doesn't have to be beautiful, but I do like to try and tidy that just a little bit. And that's probably just fine. So, to test it, I've got the face back on. Grab our power source. And we have a light. Now, these things and cameras do not get along. No matter what I do, it's going to look terrible to a camera. But to my eye, as I look at it, the light is pretty darn uniform. I've played with trying to change exposures and whatnot, and you always get this super bright light where the actual scripts are, and it looks really dull in the middle. To the eye, this is almost uniform. In a darker room, if I didn't have all the extra lights turned on, it would be perfectly fine. So that is pretty much that. The only thing left, because we did the heat insert on, we've got this little recess. I go into my screw bin. I've got, not that one, 16s. I've got a lot of M3x16 pan heads. Because I have so many of them, it's just what I've been using. I've had some trouble getting reliable supports on these tiny little holes. It either wants to put way too much or not enough. And when it does that, that means the first couple times you feed this through, it's probably going to be a bit of a pain in the butt. I've gone through already with a knife to clean up the flashing left over from the support itself. I'm just going to have to push through it a little bit. I'll get face off here for a second. Take the hex key and maybe try and push a little bit, just to make sure I've knocked all the crud out. And it looks to be a fairly clean hole. I'm going to be able to get the camera to look through it. You can kind of see it. It's a pretty clean hole. It printed accurately. The problem is just the and the way I put these together in the model, at least, I wanted to have the short end, so I get the light on, I wanted to have the short end of this on the base so that you could use a shorter bolt. If I'd put the long end of it, like we have on the face here, if I'd put this end on the base, you'd have to go through that much more to get to the heat insert. So from here, just kind of, it's annoying sound. Just kind of go around and grab all around the edges to make sure it's down and in. It's a great thing about the way these print. The friction fit alone is enough to hold them in most cases. But for this one, I decided to put in my little heat insert. So work that down. And it's got enough grab that I can't quite just freely spin it between fingers. But until I hit the heat insert, I could feel the difference there. And I'm just going to gently keep pushing this down. And after a moment, it should give me enough torque to tell me it's fully in, and that's it. So now I have a little pan head that's flush to the surface, not going to mark up your wall or anything. And on the other side of it, there's a 0.4 millimeter gap between those two pegs, so technically this has now become ever so slightly concave, but it's never coming off. Not unless you go into it with, not unless you go in and take that screw out first. So there you have it. You got a completed light box for the Deathcore Creed. Got this little keyhole to hang it off of a, actually I can backlight it now. A little keyhole we can use to hang it on the wall just off of a common little thumbtack. So that's it. That's how you build them.